that she could really concentrate and she could actually leave her body and she could fly.
Oh no, that's ridiculous.
I said, you need to be careful who you say that to, because they're gonna think you're freaking high. She got mad at me, and that's the last time I talked to her. So.
No, I could have understood if she said she has like visions and stuff, or what they call it, deja vu.
Yeah, everybody has that, but I ain't flying. I mean, you fly. They call it transcendence, or they call it something.
Astro
where you actually
projection.
What?
Astro projection.
Yeah, that's what she said she was doing. All right, here's a problem. We're gonna write it down. Well, this is continuation. Now, I realize. Okay, now I'm gonna tell y'all what happens when y'all do 10.1. Okay, this is what happens. Y'all look at the homework and you shut down and say you can't do it. Okay? So I'm expecting a lot of homework problems, but I'm going to go ahead and do some more problems today so you can actually see how it's done, because I want you to try again. Now, are there some problems in the homework that are teetotally stupid? Yes. And I will tell you those when we get to them. But I'm going to do 4 or 5 problems today that are test questions. All right? So let's go ahead and look at the first one. Y'all should be able to see my screen. I am recording, and the captions are on. So here is the first test question. Now, those that we did the other day are test questions also. So what we did last Thursday and what we're doing today are test questions. So here is the first one. I want you to rewrite this problem: sine of x, cosecant of x. Oh, crap. I hate cosecant. I can't ever write cosecant the right way. Sine of x, cosecant of x, minus sine of x. Now, what I want you to do is I want you to write this. I want you to simplify this in terms of sine or cosine. So go ahead and do that. I want you now, I will give you a hint. Whenever you see parentheses in real life, except for calculus, because that means it could be the chain rule, but whenever you see parentheses in algebra, somebody tell me what you usually have to do when you see parentheses. What do you usually do in algebra?
Distribute.
You distribute, yes. I know you're not supposed to talk, and I know that goes against the creed of the class, but I appreciate it. You distribute. So do that. That'll get you started. Ms. Reynolds, you could take astro projection, and you might be able to concentrate. You may be able to take those pictures and be able to tell the future.
I don't even know what that means.
I know. It was supposed to be confusing.
You really can't understand it unless you've tripped on acid, to be honest.
I'm gonna be honest with you. This just happened like in a 24-hour period. I'm like, one day I'm talking to the person and she's like, blah, 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 blah. The next person, she can project and she can fly and she can tell the future from your dreams. Write down your dreams and I can tell you what's going to happen to you in the future. Okay. So, Mr. Thornton, that's not much. Not until you've had astral projection and dreams thrown into your face. Have y'all ever seen the angelic people on YouTube?
Nah.
No,
Oh
I
my
haven't.
gosh. Y'all need to check that out.
Ooh.
Between homework and Miami Vice and football, I don't be having time for nothing.
Oh, listen at you. I tell you what, them Georgia Bulldogs whooped up on that Kansas. They whooped up on them. And Kentucky beat Florida. I was glad to see that. I think they're called Angelic. What are they called? Angelic. I can't remember if they're angelic healers or. Let me look it up on my. Because I got a history on YouTube on my YouTube. Let's see. Okay.
I watched a video the other day where Demi Lovato said that she can communicate with aliens by meditation.
That's interesting.
She's done lost her damn mind.
Yeah, I was looking them up. I can't look it up right now, so I thought I'd go to YouTube and look it up. That's not my YouTube. I don't have to sign in. What's wrong with this computer? Oh, there it is. YouTube. There it is. Angelic Initiative. I think that's it. Yeah, there you go. I tell you what, if you need answers, you go to the Angelic Initiative, buddy. They show you how to live right there. You think you've met some crazy people. Watch these people. They think they're angels.
I can't
Bruh,
take advice from nobody
that's
losing
tough.
force.
They actually think they're angels.
Bruh.
So you need to check out the Angelic Initiative.
How could they?
And just remember, when you think somebody's crazy, just go to the Angelic Initiative. And you'll find out right now that what you think is crazy is not crazy. All right, so what do we have here? We have sine, cosecant, sine, and sine. Everything looks good except for what? What's the only thing that kind of pops out like a sore thumb?
Cosecant.
So change that to what?
1 over
What's the
sine.
rule? The rule says always try to write in terms of sine and cosine. So what is the cosecant?
1 over sine.
Yes.
And what is this? Well, the sine cancels.
It would. You would cross both out, and so it would be 1 minus sine.
And what is 1 minus sine squared?
Aha.
Dang.
I think that's the
these
step
things,
I don't go all the way through.
these things are not difficult. Why do you have a problem with them? Because you've never done them before. And each time you do these, it's like completing the square. Each time you do them, they get quicker and quicker and quicker, and you start seeing them. But you're not going to be able to do them the first time you see them.
I have a question, Mr. Hubert.
Yes.
When do you know? How do you like? So one of the major problems with trig that I've always had with identities and everything was knowing when the problem was finished, like knowing when to stop. That was my biggest thing.
Usually, if you're not doing a proof, meaning proving the left side or right side, because you know when to stop if you've proven the left side or the right side. But with this one, usually when you've got things written in terms of sine and cosine, you're done.
Okay, that's okay. Yeah, because I was worried about like if I was finished with it or if I had to break it down even further.
Yeah. Well, thank you for communicating that. That's communication for the rest of the class. He just said what his problems were in past trig classes or pre-cal classes. That's called communication. That's a good thing. Thank you, Mr. Christie. Okay, so yes, when you have things in terms of sine and cosine, that means it's pretty much done. All right, let's do another one. That was a test question. All right, what about this one? Well, they want you to rewrite it. Sine squared of theta. Okay, they want you to rewrite it. Now remember that sine squared plus cosine squared is equal to 1. So what could we do? Let's use that. Sine squared theta plus cosine squared theta is equal to 1. Now, why did I choose this? Because this is almost this, okay? They want you to rewrite it. In other words, they'll say rewrite using the fundamental identities, okay? Well, we know that sine squared is 1 minus cosine squared, and cosine squared is 1 minus the sine squared. Well, this is like 1 minus the sine squared. So, but how can you prove it? Well, you can actually say 1 minus cosine squared is cosine squared, so you could plug that into this and say sine squared theta plus 1 minus sine squared theta is equal to 1. And that's going to be sine squared theta plus 1 minus sine squared theta is equal to 1. And what happens to the sine squareds?
They cancel. Well, subtract a 0.
And you're left with
1
is equal to 1. All right, so that's a proof. Or you could go back up here and say, well, I could take cosine squared and I could subtract sine squared. So 1 minus the sine squared is equal to the cosine squared. And that's your answer, cosine squared. So when you're dealing with these identities, there's 2 types of questions you're going to get with these identities. 2 types of questions that I will ask you on the test. Number 1, rewrite. Rewrite is like the problem we just did, and I like this one. This one right here is a rewrite. That one and the problem we just did is a rewrite. In other words, they give you something. They don't say it's equal to anything, and they just say rewrite it in terms of sine or cosine. And usually you do not have an equal sign with a rewrite. And then there is a proof slash equality. And that's the one we're fixing to do now. And it does have an equal sign. So these are the the 10.1. These are the 2 types of questions I would ask you. Now they do have some quirky questions in the homework. And there's one that I've never seen before. It gives you one trigonometric function. It tells you to write the other in terms of sine or in terms of that function or something. And I've never seen that question before. I've got to work on it. I saw somebody send it to me And I've never seen that question before. I've got to work on it. But it is not included today because it is not a test question, especially when I've never seen it before. All right, so here's another test question. Cotangent of theta over sine minus 1 plus the cosine of theta over sine plus 1. That's theta, sorry. I don't write thetas when I'm doing a proof or a rewrite. I just write cotan sine 1, negative 1, cosine sine plus 1. I don't write all these thetas. So sometimes you might see me leave out the thetas. Equals negative tan theta minus secant theta cosecant theta. And I'm going to work with the most complicated. So I'm going to work with this one. Because it's fractions. I'm going to work with this side right here. Now you don't have to, but that's what I'm going to work with. Work with this side and make it look like this side. So I want you to look at it for a minute and see what you want to do. And I would highly suggest that you think about fractions. What do you need in order to add fractions? And I'll let you work with that from there. So go ahead and think about that. What do I need to work with fractions or to add fractions and go from there? Hopefully that'll help you. Or you could just quit. It's always easier to quit. So what do you have to add fractions? Or subtract fractions?
The same base.
The common what? Denominator. So the common denominator of 3 and 7 is 3 times 7. So the common denominator of sine plus 1 and sine minus 1 is sine plus 1, sine minus 1. So sine theta minus 1 times sine theta plus 1 plus sine theta minus 1 sine theta plus 1.
So basically you merged the denominators from the separate fractions into one fraction.
Yep. Let's go back to 6th grade, 7th grade. 1 over 3 plus 4 over 7. Somebody tell me what the common denominator is.
21.
What did you do? 3 times 7 here. 3 times 7 here. 3 will go into 21 7 times. 7 times 1 is 7. 7 will go into 21 3 times. 3 times 4 is 12. You remember doing that?
Yes, I do.
Same concept.
Oh.
Nothing in common between sine minus 1 and sine plus 1. So you just what? Put them together. 3 times 7, 3 times 7. So how many times will this go into this? Well, it's the opposite. Sine plus 1 times cotangent. And how many times will this go into this? Sine minus 1. Okay, start simplifying. And remember the rule, try to write everything in terms of sine and cosine. Is everything in terms of sine and cosine?
Not yet, because we have a cotangent.
There's a cotangent there. You need to change it. Dang old cosine over sine. We've got parentheses, so, and you can put all that numerator. You can draw one BA line and put sine theta minus 1, sine theta plus 1, and then do all your work right there. So go ahead and do that. You got 2 or 3 steps right here to work on to get to here. So go ahead and do those 2 or 3 steps. First step, change that cotangent to cosine over sine. Mute your mic, please. Somebody, I hear a bunch of wind or something. So I'm going to go to magenta right here, and I'm going to change this to cosine over sine. So that's going to give me cosine over sine times sine plus 1 and cosine times sine minus 1. All right, I gave you a hint. So now, what do you do with those parentheses now? Distribute. Go ahead and do that. This problem has many steps, so we're nowhere near the end yet. So cosine sine multiplied by sine over 1 plus cosine over sine times 1 plus cosine sine minus cosine. All that over sine minus 1 sine plus 1. And of course, what happens to the sines? They cancel, Hubert. That's right, class. Thank you for that interaction. It always helps to have interaction in a class. Unless you like that person that I'll just have a water and a carrot stick. So now we've got cosine plus cosine sine plus cosine times sine minus cosine. Sine minus 1, sine plus 1. Somebody tell me what happens next. Come on.
you
Just
can turn
algebraic.
you can
What
turn
happens
the
if you have a positive and a negative? What happens to them? What happens to the cosides? Ooh. Cancel, Hubert.
They cancel?
Class. Continue.
Mr. Hubert,
Yes.
the positive cosine and the negative cosine, you can get rid of them. Like you can cross both of those out.
Yeah.
So the
That's
sign
like-
doesn't affect whether or not we get rid of it.
No, this is like X. This is negative X.
Oh, okay. So okay, I guess I could see. That makes more sense because I didn't know you could do that.
Yeah. All right, now I want you to use your algebra skills to finish it. The denominator, you can do something to the denominator to simplify it. And then you can use your law of fractions to simplify the denominator with the numerator. Does anything look familiar about the denominator? Shortcut number 3, Hubert. That's right, class. Good. Shortcut number 3. Was that Miss Davis that answered that question? I think it was. Miss Davis is like, yeah, sure. Shortcut number 3. A minus B times what? A plus B is equal to A squared minus B squared. And I'll tell y'all a little hint. If you're one of those people that was in algebra and said that you wasn't going to learn the shortcuts, then you might as well forget whatever career you're looking for, because it's going to follow you all the way to differential equations, statics, and dynamics. So if you're an engineer hopeful, you might as well learn them, because you're not going to make it unless you learn the 5 shortcuts, which I showed them to you in the review. So the shortcut number 3 will give me A squared minus B squared, which is going to be sine squared minus 1. And the top is still cosine over sine plus cosine times the sine. And somebody tell me what sine squared minus 1 is.
cosine.
Cosine squared. Now I want you to simplify it, because this is just an algebra problem. You just have to think of it as x's and y's. And what would you do with this cosine squared over 1? Finish it up. So I'm going to bring that cosine up here. When you divide by a fraction, what do? Multiply by the what?
The reciprocal.
So that's going to be 1 over cosine squared times cosine over sine plus cosine sine over 1. So that's going to be cosine over cosine squared sine plus cosine squared cosine sine over 1. No, sorry. Sorry about that. I don't know why I put it up there. All right, finish it out. What happens with the cosines?
It cancels.
This cancels, and that's going to be cosine. And this cancels, going to be cosine, and that's going to be sine.
You have a work email.
Good gracious, people blowing up that email. Tri-County Tech is dropping students left and right. I ain't kidding you. I don't know why, but they're doing it. So, what do we get here? 1 over what? Sine, cosine? Plus wait a minute. Should be a minus. Oh, I forgot about that minus sign. Hold on a second. Okay, minus cosine. That, yeah. This is supposed to be a minus cosine squared. Yeah, this is supposed to be a minus cosine squared. And that's going to make this a negative. Yeah. And that a negative. And this a negative. And this over here negative. I knew there was supposed to be more negatives. Sine over cosine. So somebody tell me what my final answer is. What is negative 1 over sine cosine? It's like 1 over the cosine over 1 over cosine. What is that? Cosecant, secant, plus what? Minus
Negative
tangent.
10.
Sine.
So your final answer is negative cosecant theta, secant theta, minus tangent theta. And what were we looking for? Let's go back to the original equation. Look what we were looking for. Negative tangent. Well, you can't see it because I can't get everything on the page. Negative tangent minus secant cosecant. So you just proved it. We'll pull this back down in case you need it. Let me ask you something. When you first learned how to factor or complete the square, were you able to do it the first time you saw it? No. Now, some of y'all that think y'all invented it, y'all might think y'all, but you didn't. And this is another factoring it's another completing the square. This is something new to you. It's going to take a weekend, like this weekend, doing 10.1 homework. It's going to take you, and you're going to have to try, and you're going to have to keep trying. All right? 10.1 homework, trying it and saying, I can't do it, is not going to work. You're going to have to try it and try it, quit, come back to it, try it again. Remember the rule. Try to write everything in terms of sine and cosine. Okay, that helps tremendously. All right, let's do a nerd. This one isn't so long. This one says no equal sign, so that means this is a rewrite. Cosine theta, or cosine squared theta, over sine squared theta, plus tangent theta, cotangent theta. And the directions are going to say rewrite or simplify into a singular trig function or something like that, into a single trig function. So I want you to take a second and work with it. The only hint I'm going to give you is I might want to focus on the cotangent and see if you can rewrite that. Focus on the cotangent, because everything else, you could rewrite the tangent and the cotangent. You could do that and see if something cancels. It would. You could do that also. Write everything in terms of sine and cosine. So go ahead and take a minute and work on it. So I'm just going to use the tangent. I'm going to do cosine squared theta over sine squared theta plus tangent theta. What is the cotangent? 1 over the tangent. So you see this goes to 1 plus cosine squared theta over sine squared theta. Well, you could rewrite this as cosine of theta over the sine of theta raised to the second power plus 1. And what is cosine over sine?
Cotan.
Cotangent theta, cotangent squared theta plus 1. And what is cotangent squared theta plus 1? By the Pythagorean identity.
Cosecant.
That's right. That's okay. So I gave y'all 3 or 4 questions that we did last Tuesday, and this is 4 questions that I would put on a test. Now, what I would do if I was you, and I'm going to shut it down right now because a lot of people say, well, Hubert, when are we going over 10.2 when you understand 10.1? Okay? And I'm going to give y'all until today. We were technically supposed to be going into 10.2, but since we missed Tuesday, I'm giving y'all a reprieve, and Tuesday we're probably going to 10.2. Well, Hubert, what about those questions that you said don't make any sense? I'm going to try to go over those Tuesday for you, even though they're not test questions. I think it's better for me to go over the test questions that I would give you so you can be working on them. I'll show you what one of those look like. That I don't want you working on them until I show you. I'm going to show it to you. So just skip them in your homework. Let's see, where is 111? I have no idea what number they are. Let's see if that's it. Yep. That right there. These questions right here are not test questions because they do not give you enough information to I think you just rewrite using the trig identities. I think that's what you do, but I haven't tried it yet. I've never seen this question before. So I'm going to work on it and show you how to do it so you can finish your homework. But I would not, don't send them. I've got 2 or 3 that's already sent. It's number 26 in the book. It's number 7. I think somebody else sent one. I think number 7 and number 9, I think. So just kind of veer off of 7 and 9 in the homework and work on these questions that want you to rewrite or prove. Rewrite or prove. Questions? Okay. Make sure you watch those angelic initiatives. And I'm going to call the roll. And I want y'all to work on 10.1 this weekend. Get it done. Because there's no use